Ladies and gentlemen of Algebra 2 Honors, friends and aficionados of Algebra 2, welcome to our Algebra 2 Honors 2022 first semester assessment of course performance. We have, what I did is this can be a compilation video. I took my 10 top scoring students and took every one of those problems they missed, and there are going to be 9 problems here. So we're going to see what the most missed problems by the most advanced students were. And so as far as overall, the test was heavily weighted towards systems of equations problems, and students did great at them, like problem 1, no problem. I only had one of these top students who missed this problem too, but I want to still go over it to kind of show you how to do this one. And there really are a number of ways of doing this one of which is to play it straight with this general form of an equation for a parabola. And so we can use these 3 points to create a system of equations and use that to solve. So we can take this, the points 2, 1, and so that's going to be y equals, so I'm going to put y equals 1, replacing, so that's the first point. And we're going to have this one right here, a, and x is going to be 2 squared, plus b, we don't know what b is, but we know x is 2, and then we have plus c. So that's going to be our first equation. Our second equation we're going to have is this, this second point, 4. So 4 equals a times negative 1 squared plus b times negative 1 plus c. So that's our second equation, and our final equation is going to be 3 is equal to, we have negative 2, so a negative 2 squared plus b times negative 2 plus c. And so after when we work all these out numerically, we get 4a, that's this first equation here, plus 2b plus c is equal to 1. And then we have, for the next one, we have negative 1 squared is 1, so we have a minus b plus c is equal to 4. And then we have, finally, we have this last equation, we have 4a minus 2b plus c is equal to 3. And we take these, we can take these equations and assemble them into an augmented matrix like this: 4, 2, 1, 1, and 1, negative 1, 1, 4, and then we have 4, negative 2, 1, 3. So that's one way of doing this, and we would be able to see what our answer is. Now, one thing in our 7th period class, Simon had another way of doing this, and that's to assemble these 3 points in a table like this, where we have x, y, and just put them in like this: 2, 1, negative 1, 4, and negative 2, 3. And I did go ahead and enter this in the calculator. So we go to Stat, Edit, and I entered these points previously. Here they are entered. And Stat, Edit, Stat, Calc 5. And so we get A equals negative, so we're going to have negative 0.5 x squared minus 0.5 x plus 4. So negative 0.5 x squared minus 0.5 x plus 4, and our answer for that is going to be C. But the easiest way to do this, and I suspect maybe you have a limited amount of time on a test, maybe just going ahead and enter these in the function editor and checking them out in the function editor, see which one is right. That might be the easiest way to do this problem. So only had one of the top students miss this one. Now here, problem 3, we have another system of equation problem. Basically, it's you have a text of a system of equations, and you're going to try to figure out which one of these answer choices best matches the text of the problem. And the people picked as their answer this one, A. I think of these students, I only have one who actually got the right answer. But if you pick A like this, and if you look at the distinction between A and C, there's only one difference, and that's that last equation, that this 8n equals P. And so if we take this 8n equals P and we go ahead and use it to put this in matrix form that I started below here, you can take this, if you subtract P, we have 8n minus P is equal to 0. And when you go ahead and put that into the form you have, you're going to have negative 1 for negative P plus 8, and that's going to be equal to 0. And so that's what you get for answer choice A. Now, if you look at answer choice C, what you have is you're going to have 8P minus n equals 0. So what you're going to get for answer choice C is 8 here and minus 1 equals 0. So it's going to be between these two, A or C. And I think the problem that people had was figuring out this one. If there are 8 times as many nickels as pennies, so if you're not super careful, you're going to say 8 times as many nickels as pennies, and that seems to be a direct translation of the text. But my recommendation for this is to just kind of think things through. So what you mean, you're going to have 8 times, if you take the pennies, to have 8 times as many nickels as pennies, you have to multiply the pennies by 8 to get the nickels. And so this is not going to be the correct solution. The correct equation is going to be your nickels are going to be equal to 8 times the pennies. And so that's fundamentally why C is your right answer. But if you'd had the time and taken the time, I'm going to show you what you have now. What I did is I entered this into a matrix. And I'm going to go to second matrix and go to edit and show you this is answer choice A entered. And if I go here and clear this out, let's say second, that's what I do, and I go to second matrix math, and I'm going to go down to B, which is your reduced row echelon form. And there it is. Press enter. And I'm going to go to second matrix, enter, and then we enter this, and for our answer here we get all these decimals, like 83.32 pennies, 10.415 nickels, 19.264 quarters. Now, so that usually when I work out a problem, like a system equation problems, it'll be one that I found or one that I've written myself. And in most instances, I'm going to go ahead and try to make something that will work out. And so this one here obviously is not an answer that would make sense, even though there's a possibility this could be right. Let's go ahead and enter. We're going to fix that matrix here. I'm going to go back to the matrix, and I'm going to go to Edit, and press Enter. And what we're going to have here is we're going to have 8 pennies here, and then -1 nickels, and everything else is the same. And now I'm going to go ahead and press second quit, try it again. Press second matrix, and we're going to go to math. I'm going to go straight down. I'm going to press alpha B, and then I'm going to press second matrix, enter, and then enter. And here we get an answer that makes sense. These integers, 12 pennies, 96 nickels, 5 quarters. So that underlines that C is our correct answer for that one. Okay, next we're going to look at, we're going to skip ahead here to problem 11. And problem 11 was one that a lot of people missed. And let's get over to number 11. Here we go. Okay, if the quadratic function in standard form h of x equals negative 2x squared plus 20x minus 44 is converted into the vertex form fx equals a times 20x minus h squared plus k, what will be the values of h and k? Now, so for this, the main thing that would help you to understand this is the vertex of a parabola is going to be the coordinate pair h, comma k. And so what will be the values of h and k? So if we find the vertex of this, that will tell us directly what h and k are. And so if we go to, we're just going to enter this and graph it, see what it looks like. So, so I've already previously entered this function in red. If I go to zoom 6, we get this looking thing here. So we get h is going to be 1, 2, 3, 4, 5 to the right, and k is 6 up. And we can go ahead and hone in on that using second trace. I'm going to go for a maximum 4, which says left bound x equals 0. So to the left of the, so anywhere to the left of the maximum, we can press enter. And then it says now right bound question mark. So now we can go over to the right of the vertex, press enter twice more, and we get a maximum of 6 where x equals 5. This is this 4.99999. This is like 3 10 millionths off. So that's just the little rounding here. So it's going to be, in this case, we're going to have 5, comma 6. And so what that tells you is that h is 5 and k is 6. Now you can also use completing the square to do this one, but to me, just graphing this and understanding what the role of h and k are. Okay, so that's going to be number 11. Next one we get to is number 12. What is the function of 2x squared plus 12x minus 3 in vertex form? I really saw my advanced students on this one use completing the square, and so I'm just going to go ahead and do it this way, even though you can graph each of these in the calculator separately and check which one is right. So we're going to have f of x. We have the coefficient 2 of x squared. We bring that out front. So we have x squared. And then what times 2 equals 12x? Well, that's going to be 6x. And then we're going to add something to complete the square here. And we're going to subtract something over here on this side. And finally, we have minus 3. And then we can have our Dr. Hoffen square. Well, we have 6 divided by 2 is equal to 3. And we take the 3 squared. That's going to be equal to 9. So what we're going to get is 2 times quantity x plus 6x. Well, it's going to be, I'll put the 9 here. Now here's where some people get into trouble. And what happens is you have to realize that do you subtract 9 from this? No, you don't, because what you did is you added not 9, but 2 times 9 or 18. So what we have is we're going to have minus 18 on the right. So these are equivalent. And so what we're going to get for this is 2 times quantity x plus 3 squared. And then we have on the outside negative 18 minus 3, so minus 21. So that's going to be our answer. Let's see, which one is this one? That's going to be answer choice A. Okay. Very good. Next, we get to number 16. Find the solutions to the following equation. I got a lot of people who for some reason got answer choice D. I can't exactly figure out. I have to look through the test to figure that out. But one way to do this is by graphing to see which one is right. And what you can do for this is you can graph, and we did this in class this way, you can graph these two equations separately. And to do that, you would have an equation y equals 2 times quantity x, that's the value of quantity x minus 5 minus 4, and separately you'd graph y equals 2. And then you'd see where if and where these, obviously you're going to have at least one solution here based on the answer choices. So let's go ahead and go to our calculator. And what I did is I entered these equations in advance. So I'm just going to highlight them so they will go ahead and show when I graph them now. And I do. And you're going to get x equals 2 and x equals 8 right here. Those are the answers. X equals 2, x equals 8. Separately, you can do this as 2 times that's the value of quantity x minus 5 minus 4 equals 2. And you can just set about solving here. 4. You get 2 times that's the value of x minus 5 equals 6. Divide by 2. So we have x minus 5 equals 3. And also we have x minus 5 is equal to negative 3. And this is how you get x is equal to 8. And x is equal to 2. Okay. Next problem, we're going to have problem 24. You can see I've skipped over a lot of problems here, and that means you guys did great. So there's a function given by fx equals quantity x minus 3 squared plus 1. If the function h of x is obtained by translating f of x 4 units to the left and reflecting about the x-axis, what is the function h of x? And what I did is I also previously entered this into the function editor. And so we go right here and I come down. So I'm highlighting it right here and then graphing. And so we see we have the vertex here. And so what we want to do is we want to translate this graph 4 units to the left and reflect it about the x-axis. And so what you're going to have is you're going to have something that goes, that opens up like this. I'm kind of tracing it over. It's going to move to the left. And that's another thing, move to the left. So you're going to have x, instead of x minus 3, you're going to have x plus 1. And then you're going to take that plus 1 and move it down. So you're going to have quantity x plus 1 squared, and then this plus 1 up here where it starts becomes minus 1. And so you're going to get this one right here, which is answer choice. I believe it is A. Okay, and x plus moves to the left and x minus to the right. So x plus, so 4 units to the left, x plus moves to the left. So if you add 4 to negative 3, that's how you get the plus 1. And then you moved it 4 to the left, and then you could also graph that to see which one way. I'll do that quite easily here. Let's go back to the calculator just to verify. There should have been more than enough time to do this. I haven't talked to anybody since this, but we have negative out front. We have x plus 1 squared, and then we have minus 1, which is going to reflect about the x-axis graph. And that's exactly what it is, this red one. The Christmas colors, green and red. Hope everybody had a great Christmas. Okay, next we have problem 28, which is a couple of my most advanced students missed this one, and I had trouble figuring out how it happened. But basically, what you have here is you're given 2 points. This is very similar to one we worked during class, and I let people know you're going to have one like this on this test. And so basically, I told the class in the review that what probably works best is to set your XY coordinate plane based on this point 0, 10 being along this y-axis, and your vertex being, of course, 10 feet below that. So basically what you're going to have is you're going to have y, or f of x, equals a times quantity x minus h squared plus k. And here what you're given is your when you set this y-axis right here at the center span of the bridge, you have h is equal to 0 and you have k is equal to 10. So we have f of x equals a x squared plus 10, and then you can substitute in the points given. The only other point we're given here is this right tower, and so what we get is f of x equals 500. So we have 500 equals a, and we have x is 2100 squared plus 10. And then you subtract 10, you have a times 2100 squared equals 490. So a is going to be equal to 490 over 2100 squared. And to me, that's probably the easiest way to enter this. And you go to the calculator. Let's do that. So I have oops, I want to clear that out. Okay, so we go to alpha enter 490 over 2100 squared x squared plus 10. And so that's going to be your function entered, and then you can check to see where you are. And then what I did is I previously entered this into ask. I'm going to do that again. I'm going to start at table start 0, not that it makes a difference. I'm going to go to ask. And when you go to ask, you're given a clean slate here. So if I enter 0 for x, I should get 10, right? If I enter 2100, I should get 490, or no, I should get 500. That's right, I get 490 because it'd be 490 plus 10. And then it says from the right of the center, well, the center is at 0, and so if we go 1100 feet from the center of the bridge, what we're going to do is we're going to just put 1100 right here. Oops, that's 11,000. 1100. There we go. And then we press enter. So we get 1300 over 9. That's going to be, let's get this here, 1300 over 9. So 144.4, I think it says to the nearest foot, right to the nearest foot. So 144.4, okay, that's going to be 144. So 144 is going to be your answer. Now, I had one of our most advanced students who somehow got this wrong, and I was trying to figure out how she got it wrong. And what happened is I happened to see that for some reason she had marked over here point of not 1100 but 1000 instead, and so that made the answer off. So anyway, that is our answer to this problem here. We have a couple more. We're going to go over 29. How many solutions are there to the equation? I've had some, let me see, I want to get this one in the field of view a little better. Yeah, this one here, I'd had some problems with this one because somehow people were thinking instead of what they kind of mistranslated the text of the problem. Instead of how many solutions, they somehow said, what is the solution? What are the solutions? And so when you do that, that's gonna make your thing a little harder. Now, how many solutions to an absolute value equation are there? Well, there are really only 3 possibilities. So if you have okay, you can have 0 solutions like this. You can just touch that other line to have 1 solution, or if you go below and up above here, you can have 2 solutions. So your possibilities for this problem are going to be just 0, 1, and 2. And so you can graph this one on both sides. So if you see here, when you add 3 to both sides here, you're going to get 5 times quantity 2x plus 4 is equal to 0. And this is a telltale sign there's only going to be 1 solution if you have the right side equal to 0. If you have the right side equal to a negative number, that would be no solutions. If you had the right side equal to a positive number, that would mean there would be 2 solutions. So that's basically that one. And you can go ahead. I had students I saw that actually solved this out, and you got and put down -2 as an answer to this instead of 1. just misreading the problem, which was really easier than they made it out to be. And then the last one we're going to go over here is 30. And 30 was another system of equations problems that students overall did just great on. And I'm going to go ahead and quickly do this. I think I only had one of my top students miss this one. Nevertheless, I'm going to go over this one again. Now, basically, what you have is, I'm going to write this out, what it is. If you write this out in augmented matrix form, you're going to get 1, 2, 1, 8, 2, 1, negative 1, 4, and 1, 1, 3, 7. And so our answer is going to be looking like, I'm going to put it down here like this. So when you work this out and you get a solution in reduced row echelon form, your answer is going to look like this: 0, 0, 0, 0, 0, 0. And then you're going to have your X, Y, and Z. So X, Y, Z will be these numbers right here to the right. So let's go ahead and enter this in there. Okay, I go to the second matrix, and I'm going to go down to edit. I'm going to go down to enter second matrix B, and I'm going to have a 3 by 4 matrix, and just enter these numbers in here, which are 1, 2, 1, 8, 1, 2, 1, 8, and then we have 2, 1, negative 1, 4, 2, 1, negative 1, 4, and finally the last row is going to be 1, 1, 3, 7, 1, 1, 3, 7. So we've entered that. I'm going to go ahead and quit here, and I'm going to go to second matrix, and I'm going to go down to go to math. I'm going to press here alpha B, and then here I'm going to have to be careful here because I can't just put second matrix enter. I have to go down and fetch matrix B. So I've done that now, and I close that with parentheses, and we get this this 1, X is 1, Y is 3, Z is 1. So we want to have the Y value. So that's going to be, X is 1, Y is 3, and Z is 1. So we want the Y value, so 3 is going to be our answer here, and that's it. So students did great on this test. Always we strive to do better, but we just try to learn from our mistakes and move on. Good luck, and as always, thanks for viewing.